Hello, everyone, and welcome to Quacking the Code to Multi-Tenant Embedded Analytics with MotherDuck and GoodData. Thank you all for being here. My name is Jessica. I am with the marketing team here at GoodData, and I'll be moderating today's webinar. But first, I'd just like to go over a few housekeeping details. If I can find my screen. So we'll be joined by Alex Monahan today from MotherDuck. We will also be joined by Jacek or Jan Soubusta from GoodData. And just so you guys all know, you were muted upon entry, but we do have a Q&A box down at the bottom of your screen. So drop in your questions there. We have one of our senior solutions engineers on hand, so he can answer your questions as we go along, but we'll also save some questions for afterwards, and we'll have a live Q&A with your presenters. We'll also be sending you a follow-up email in the next day or two with the recording from this session, so you can watch it again or share it with your colleagues. And we'll also be including a quick survey about your experience with the session, so we'd love to get your feedback. So now on to introducing your presenters. So like I said, we have Alex Monahan from MotherDuck. Alex is a forward deployed software engineer who's been with MotherDuck for the past year or so. And for the past maybe 3 years or so, Alex has been writing blogs for DuckDB Labs. And like I said, we also have Jan Soubusta, aka Jacek from GoodData. Jacek is a distinguished senior software developer with a focus on back-end services and data sources. And he's been working with DuckDB and MotherDuck for the past couple years. So welcome both. Thanks for being here. So onto our agenda. So first we'll hear from Alex with a little intro to MotherDuck and DuckDB. Then we'll hear from Jacek about how GoodData was able to integrate with both of these services. Afterwards, we'll have a Q&A, so please, again, remember to drop your questions in the Q&A box below. And before we jump in, I'd like to give you a quick introduction to who we are and what we do here at GoodData. So simply put, GoodData is a modern BI platform for tomorrow's analytical needs. So GoodData is known for simplicity. GoodData offers a low-code and no-code approach for analysts and business users, but also offers integrated data science for developers and AI-driven automations for everyone. GoodData's flexibility allows you to embed your analytics anywhere with any endpoint to create different user experiences. So GoodData offers SDKs, APIs, and SQL endpoints. We also help with productivity. With the analytics as code approach, this enables reusability and composability of your analytics. And there's also easy tenant management thanks to the inheritance model of the platform. And finally, GoodData allows for scalability. Governance controls ensure everyone sees the same and correct numbers, and query acceleration and caching actually can help to reduce your warehouse spend. So without further ado, I'll pass it over to Alex. So Alex, take it away.
Wonderful. Well, thank you everyone for being here. Really great to talk with you. Let me share my screen. All right, well, welcome. Well, I'm thrilled to get to talk to you today about MotherDuck and our partnership with GoodData. So MotherDuck is a cloud data warehouse for the rest of us. So what if a cloud data warehouse were architected for the size of data we actually have, not the petabytes of data of big tech? How much lower latency could it be? How much faster could it be? How much easier could it be? And especially how much more efficient could we be? So what is MotherDuck? Well, MotherDuck is a serverless cloud data warehouse, and it's based on top of the open source engine DuckDB. And we'll talk more about that shortly. And we really are designed for low cost, easy, low friction analytics, but we can scale to support complex apps and data. We want to do that in a much more efficient way. And we'll hear more details as we go. We are also now generally available. So we have just recently launched. We were in beta for about a year, and now we are officially launched as generally available. And so easy data is here. And I love our little duck icons. The roller skates, this one's definitely my favorite. So of course, the duck puns will flow. We are the ducking simple data warehouse. Don't worry, they don't necessarily get better from here. At MotherDuck, we are an efficient data warehouse, and we're taking DuckDB from a single player experience into the cloud. You can start with a 30-day free trial to get the full horsepower of MotherDuck, and we do have a free forever plan for smaller projects. So it's really easy to get started. We're perfect for your hobby projects, but we encourage you to also try that free trial to see the full horsepower. And it's motherduck.com. So we talked a bit about MotherDuck. Well, what is DuckDB? What are we built on top of? Well, DuckDB is a lightweight in-process SQL analytics engine, and it's taking the data world by storm because it can go anywhere. Runs in 15 different languages on all the major operating systems, all the major CPU architectures, even in your web browser. So it really can go anywhere. So while I'm talking here for the next couple of minutes, really 3 questions I want you to keep in mind. Why did we create MotherDuck? Why rethink the cloud data warehouse? There are several available. What is different about MotherDuck? We'll talk about the details of what's under the hood for MotherDuck, and then we'll cover what experiences become ducking awesome based on that. What does that, what value does that provide in your daily work? How do we make your work better and easier? So why are we creating MotherDuck? Well, we believe that we see some changes in the industry that the rest of the industry hasn't seen yet. And the first one there is that big data is dead. Now, that's obviously a clickbait way to say it. What we truly believe, though, is that big data was more marketing than reality. It didn't expand out from big tech like people predicted. And really, most people don't have big data, or if they have a lot of data, they don't look at all of it all at the same time. And because of that, you don't need to design your system focused on the size of data. You can design it for ease of use. You can design it for low latency and speed. Laptops are also incredibly powerful. How do we use that compute that you've already bought that's sitting on your desk idle, like a mainframe terminal when you usually go to the cloud? How do we use that laptop? Servers are also enormous. Whenever you rent a small machine on the cloud, what you're actually renting is a very small slice of a very big machine. Why not rent the whole big machine instead of many tiny slices? How much more efficient could we be? And then we believe that everyone loves DuckDB. We do, GoodData does. We're excited to talk to you about that. We think it's an excellent ingredient for both MotherDuck and GoodData. So what do we mean when we say big data is dead? What's the evidence underneath that clickbait title? Well, our CEO was one of the founding engineers of BigQuery, Jordan Tagani. And while at BigQuery, he analyzed some of their usage patterns, and 95% of customers had less than 1 terabyte of data. Well, I can fit that on my laptop. That doesn't feel like big data in 2024. At SingleStore, where he also worked, 80% of their customer base was on the smallest instance size, and they kept asking for smaller. Gartner and Andreessen Horowitz also agree most people don't have very large data sets. So it's really multiple different data sources are telling us that big data is just marketing. So what will we do with that knowledge that we believe we've internalized that the rest of the industry hasn't? Well, we should make data easy. DuckDB does an excellent job of this. So this is about the open source side. The analogy we like to use is a hamburger. We believe most of the database industry is focused on the hamburger patty. How can the query execution time be as low as possible? But what they neglect is the user experience, the bun, the cheese, the lettuce. A soggy bun is going to ruin your hamburger. And if it takes forever to import your data or export your data or get connected, well, it's going to ruin your analytical experience as well. DuckDB is easy to install. There's no dependencies, so you can add it in any kind of workflow that you have. It runs anywhere, even in the web browser, because it's so embeddable. And you can query data frames directly in Python or R. So you can query Apache Arrow or Pandas or Polars. And it has the friendliest SQL syntax in the world. And we don't say that lightly. We truly believe it. And other cloud data warehouses have actually started copying DuckDB syntax specifically because it is world leading. And that impacts you. That makes analytics easier. And that's not just query time. That's time from question to answer that gets faster. So how do we take DuckDB and bring it even further? How do we do that here at MotherDuck? We have added a new storage layer to DuckDB, and that allows you to do things like zero copy clone your database. And we've built the foundation for full Git operations on your database. We'll see that on the next slide. We're also serverless. The pricing model, the usage model, actually has a big impact on what it feels like to use a product. So you only pay for what you use. Makes for much more flexible usage of the platform. And it fits really well with GoodData as well. The BI workload fits incredibly well into this pricing model because it's very bursty. You need it, all the horsepower you can right when you load your dashboard, right when you're doing your analytics. And then when you're not looking at it, you shouldn't be charged. We also allow you to pull directly from Postgres and MySQL, and you can do that in SQL rather than using an external tool. That's a great way to get started. We do have excellent partners as well that do ETL, that do other ways to integrate your data, orchestrating, et cetera. But that's really great, after you get started. We want the on-ramp to be as easy as possible. Again, that easy data approach. And lastly, DuckDB finally unlocks local development, and MotherDuck unlocks production deployment. So you can change one configuration line and go from local development into production deployment. And really, we in the data space have not had that. It's a luxury that our software engineering counterparts have lorded over us and said, look how easily we could test everything. And now we can do it too. So let's talk a bit more about those Git operations. So today we have the ability to do zero copy clone of a database. So you can instantly take a snapshot, just a zero copy snapshot of what you're working on. And you can work with that data with no fear of breaking production. Really great developer experience. And we've laid the foundation to do full Git semantics, branching and merging, diffing your data itself, including full time travel. So what's the big value here? Well, if I branch my data and I work on my dev branch and I do my dev processing, and then I like my result, today I have to go rerun that whole pipeline on prod. But once we have the ability to merge, you'll just take dev and turn it into prod, instantly cutting your spend in half and making deployment fast and instant. So if big data is dead, we focus on making it easy. Well, if laptops are powerful, we should move our work locally whenever we can. This is all about MotherDuck's dual execution. Whenever you connect to MotherDuck, you're going to have a copy of DuckDB running where you connect from and in our cloud, and they're going to work together. So even our JDBC driver has the entire DuckDB engine embedded inside of it because it's so portable. And that means you can run it anywhere. So when you submit a SQL query, we're actually going to download our catalog, which is information about where all the tables are in your database. And based on that, it's going to decide, are your tables local or are they in the cloud? And in this case, this is a cloud example. We'll go ahead and send that query plan off to the cloud. It will execute right next to where your cloud data lives, which is perfect, nice and fast, and you'll get your results back. The magic secret sauce comes once you're working locally. So maybe your first query is taking a really giant data set and bringing it down to something more manageable. But then you want to slice and dice it. You want to aggregate it. You want to pivot it. You want to filter it. If you've already cached that data locally, all of those operations are instant because there's no network latency, and they're free because you've already paid for your laptop. And so this is really, we think, a key differentiator is that dual execution. We even have the ability to do, within one query, we can do some of both. So you can mix and match and combine your local resources with cloud resources. And we're going to make the optimal choice for you to take advantage of both. So if servers are enormous, what should we do differently as an industry? Well, we should scale up as far as we can before scaling out. So as a case study, let's look back at one of the most influential papers for database design. And this really is how an entire generation of cloud data warehouses were designed. A decade of cloud data warehouse design came based upon this paper, and that's the Dremel paper from Google. And in 2010, they used 3,000 nodes to solve their problem. And we're going to compare the processing power of those 3,000 nodes to one node that you can rent on AWS today for $11 an hour. That one node has many times the CPU performance, many times the RAM performance. It has more SSD space, and it has more RAM bandwidth and SSD bandwidth. Again, this is one machine versus 3,000. The only case where one machine doesn't keep up with 3,000 is in network bandwidth. And that's about to change with 800 gigabit per second networking. Now, the part that's also key about this is the very last bar, is the cost. That one beefy machine is far cheaper than the 3,000 machines from 2010. So back in the 2010s, when the current iteration of cloud data warehouses were designed, they used many, many tiny nodes. How much more efficient can we be if we work with one giant one? Another way where we can be much more efficient with MotherDuck is around bin packing your workloads. Today, if you have a set of customers, you're going to start out with one instance for all of them. And then gradually you'll increase that instance size as your business grows until you reach the limit. And once you reach the limit, then you're going to take your largest customer and you're going to have to give them their own instance. And then your second biggest, and your third biggest, and your fourth biggest. And suddenly you're managing a fleet of data warehouses, custom based on how big your users are. And you're having to decide, do I pack people together or give them their own? If I've got 100 people using the same instance, who's the one racking up all the costs? How do we optimize this? At MotherDuck, you don't even have to worry about it. Every user will get their own isolated environment, and we'll handle all the bin packing on your behalf. So we make sure you get all the compute you need in a very efficient manner. And each user, you'll be able to see how much compute they're using, and you'll be able to see exactly what they're working on. So really removing that from something you have to worry about. And we call it the personal data warehouse. So if everyone loves DuckDB, let's supercharge it. How do we take more advantage of it in MotherDuck? This is to make the case that everyone loves DuckDB. About 1 year ago, it had about 10,000 GitHub stars, and it is almost at 20,000 1 year later. So that growth trajectory is truly becoming exponential, and that's why it's a great ingredient, both at MotherDuck and GoodData. So how does DuckDB pitch itself? Well, it is simple, easy to install, it's portable, runs everywhere, and it's feature-rich. It has that great SQL dialect we talked about. It's also fast, it's extensible, lots of additional extensions, and it's open source, it's MIT licensed. You'll notice that fast is 4th place. That's because the developer experience is what's critical at DuckDB. But make no mistake, it's also fast. It's leading in some industry standard benchmarks, and it has the developer experience mindset as well. Truly the best of both. So how do we take that further at MotherDuck? DuckDB is fundamentally a single player experience. And with MotherDuck, we allow multiple people across multiple different machines to access the same data. So you can use it across multiple processes. We've got sharing, so you can easily share your data with your team, and we'll scale with the cloud. If you need to have something more powerful than your laptop, we can help with that. And we're a fully managed serverless platform. So we're taking that DuckDB ethos of ease of use and bringing it into the cloud with us. So that's a look under the hood of MotherDuck. We believe by being built on DuckDB, we can be fundamentally more efficient as a scale up multi-tenant serverless platform in the cloud. And we also believe that having that dual engine execution allows us to use those underutilized compute resources right next to where you are. So now what becomes ducking awesome? Well, data exploration can be instant. All that follow-up analysis can be at the speed of thought, 60 frames per second. If you're a data team, your local development pushing to production is one config change. And if you have a data app, you get blazing speed and rich interactivity. And we will see that with all the interactivity that you get with GoodData. So really a great combination. And please put your questions in the chat. Really looking forward to answering them as best I can, and really looking forward to talking more.
Great. Thank you so much, Alex. So now we'll pass it over to Jacek to dive a bit deeper into a real-life use case of how GoodData was able to integrate with MotherDuck and DuckDB. So Jacek, over to you.
Thanks. Thanks, Alex, for the introduction. As you can imagine, I am quite a huge fan of DuckDB and MotherDuck for like a couple of years. Actually, I am a former database specialist. I worked with databases like Oracle and SQL Server in the beginning, and then with cloud data warehouses like Snowflake, BigQuery, and Redshift. But I think like DuckDB and MotherDuck is different, exactly how Alex described. And that's why I am a member of their community for some time. And I also implemented an integration in our platform. But before I start, I would like to share with you that you shouldn't suffer from Stockholm syndrome anymore. we can see many prospects, many our customers, many people from outside the company who are actually okay to wait like tens of seconds or even hundreds of seconds for their reports. They are afraid to change anything in their analytics because they basically don't know what it can cause. And they are very often financially bleeding from their data stack, and especially from cloud data warehouses like Snowflake. And they can't imagine that it could be different. So let me show you it can be different. And what we have developed in GoodData is actually something what we call Analytics Lake, which is powered by DuckDB execution engine. And in my demo, I will show you in a few minutes, we are querying MotherDuck as a cloud data warehouse instead of Snowflake. So this is just a high-level picture, high-level diagram, architecture diagram of our platform. And you can see here the analytics lake, which actually consists of two parts. The first part is a semantic layer, where we basically describe the whole analytical solution with some metadata. And thanks to that, we can generate SQL queries out of the report definitions. And then there is an engine which we call FlexQuery. It's powered by DuckDB. And this engine is responsible for querying data sources like MotherDuck, caching the results or pre-aggregations, and then post-processing these caches by various SQL transformations, like, for example, pivoting, sorting, even some kind of machine learning, and so on. Okay, so this is our architecture, but let me show you something real. And so let's start with actually how the data comes to GoodData. Yeah, so this is a blueprint of data pipeline I created and open sourced, and it's actually currently running also on top of MotherDuck. Specifically, I am using Meltano and DBT open source tools for extracting, loading, and transforming data, and then GoodData for the analytics. And luckily, all these tools provide like definitions of the solutions as a code in various YAML files. So you can like version and deliver everything as code. In my case, it's in GitHub, but you can do it in GitLab as well. So once the data are extracted, loaded, and transformed, by the way, in my case, data are coming from GitHub and Jira, we can use the data in our analytics. So let me show you how it can look like. This is actually a production environment running in US East region, which is actually quite far from me because I'm now in Prague, but hopefully it still will be fast enough. So what you can see here is something what we call logical data model. We create this model on top of the physical database model. From tables. Here is the list of the tables available in MotherDuck. Actually, this is the definition of MotherDuck data source. You don't need to specify nothing else than the credential, the token, database name, and schema. And then we scan tables for you, and we auto-generate this kind of logical data model. And what is the added value of the model? So we distinguish here attributes and facts, which improves end-user experience for business users. We also define relationships between datasets, which is important for the generation of SQL queries, specifically joins. And we also define specific date dimension datasets where you can specify what date granularities you want to use in your solutions. Then we also provide metrics. We actually implemented our own metric language, which is much simpler than SQL. So let me just quickly show you how it can look like. So let's calculate the ratio between count of commits and count of pull requests. These are already created metrics, and you can see their definition here. So let me just run it without any context, without any dimension. And the overall ratio is 2.21 commits per pull request. We also show the generated SQL query here. And you can see here that it's running on top of two different tables. Yeah. So I can like save this metric, and I will use it later. In our, we call it Analytical Designer, which is a simple drag and drop tool for business end users. So I can find the test metric which I have just created and calculated, and I can put it into some context. For example, I can slice it by GitHub repository. Okay, and now it's slow. And it's slow because there is a bug in DuckDB JDBC driver, and it will be fixed tomorrow, actually. Okay, so I can create like bar chart, and I can like compare it quarter by quarter, and call it test. And save it. And then we can go to dashboards. I already created two dashboards, one analyzing data from GitHub and one analyzing data from Jira. So I could like edit the dashboard and add the test visualization and save it. Yeah. And that's basically a simple walkthrough through GoodData platform. But actually, many GoodData customers do not want to use our UI. They are not satisfied with it from many reasons. Yeah. Many of them also want to embed the data, the result of the reports, into completely different data applications, yeah, like their custom business applications. And for that, we expose various SDKs and other tooling. So first of all, we provide JavaScript or React, but we support also other frameworks like Angular, SDK. So let me show you a custom application I created. By the way, as I have already mentioned, I am a database specialist, not a front-end developer. So it's not that great, this application, but I hope it demonstrates the principle. Yeah. So what you can do, you can like embed the whole dashboard, even with the whole interactivity. You can like change the filter, you can edit the dashboard, you can do everything what you can do in our UI. You can also embed a single visualization, but you can also create a custom visualization, which is not supported by GoodData. Yeah. So here, actually, I am analyzing data even from different data products, from different GoodData workspace. It's not GitHub and Jira, but it's from Federal Aviation Administration dataset, which is public. And I am analyzing traffic density of flights across the United States. But I can also go to the source code. Actually, here you can see the source code of this custom visualization. And I can change like what should be analyzed. I'm analyzing number of flights, but not between regions, but between manufacturer, and the nickname is actually the nickname of a carrier. So when I save this, the visualization is re-rendered in a few seconds, and you can see the manufacturer like Boeing, and he is mostly used by Southwest carrier. Yeah, so this is how quickly you can develop locally with our UI SDK. But what if you are not a fan of JavaScript, but you are a fan of Python? So for Python developers, we provide Python SDK. And so, for example, in Jupyter Notebook, you can like import our libraries. So let me try. It works. You can define your environment where you want to connect, and then you can like simply list metrics, our stored metrics. But you can also execute a report which is already like defined in GoodData, or you can even define a report on the fly. What metrics should be analyzed and by what it should be sliced. And again, when you execute it, you get the raw result, and you can do whatever you want with that. For example, embed it into a Streamlit application. And regarding UI SDK, you can do even much more crazy stuff. For example, at the last GoodData hackathon with my colleague Dan Homola, who is much more experienced front-end developer, we created this project, VR Analytics, and we demonstrated it with my Meta Oculus Quest headset. So you can like go through the 3D visualization, and it's sort of interactive even. And it was like really a huge fun to develop that. Okay, so everything this was running on top of MotherDuck, but what about the DuckDB? So as I have already mentioned, we use DuckDB inside our FlexQuery engine. So let me demonstrate the FlexQuery engine itself without GoodData. By the way, we are thinking about even to open source it. So here is a Streamlit application running on top of our FlexQuery engine. And this setup is executing this query, which is actually TPCH number 4 query. And one table is stored in Postgres or Snowflake, and the second table is stored in AWS S3. And we are like crawling the data and store them in a FlexQuery in a form of arrow tables. And then we crunch these caches with DuckDB. Yeah. So first of all, let me like change the cache key so the cache is not hit. And now I'm joining data from Postgres with data from AWS S3. And in 6.9 seconds, I'm capable of doing that. But what about if I change the group by column? Then I don't need to contact Postgres and AWS S3 anymore. So it's like 10 times faster because just DuckDB is crunching these arrow tables. And then I can like just rerun the same query. And now this is the perfect cache hit. We are just getting the result in a form of arrow table. And it takes like a few tenths of milliseconds. Yeah. So this is exactly how our FlexQuery engine can work, and how it can not only speed up queries, but also save a lot of costs, because you are not querying Snowflake or Postgres, but instead you are querying our FlexQuery engine. Okay. So these were like all demonstrations I prepared for today. And there is one coming soon I would like to share with you. In the next quarter, we would like to extend our FlexQuery engine with AI-related features. And this is just a high-level architecture picture how it will look like. So what we enable, we will implement a full rack architecture with a vector store and graph store. And instead of like sending all the metadata from GoodData as a context to a large language model like GPT-4o in OpenAI, we will search the vector store for only relevant metadata and ask LLM with the relevant context for like how the report should be created or how the metric should be created based on the input question in a natural language. So this is coming soon. Okay, so let me just quickly recap what I have just presented. So the summary. We can provide truly responsive analytics thanks to GoodData semantic layer, DuckDB crunching the caches, and MotherDuck as a data source. And why does it work? So first of all, DuckDB and MotherDuck are state-of-the-art technologies, much newer than the traditional cloud data warehouses. They are laser focused on the analytics. There are, for example, no database clusters and no distributed execution plans. So the low latency is possible. And last but not least, they provide competitive pricing. You can go to MotherDuck.com and you realize that it's really competitive when you compare it, for example, with Snowflake pricing. And what's next? I would like to extend my demo with real multi-tenancy example. All the technology is already there, like multi-organization setup in MotherDuck is possible, as well as multi-tenancy setup in GoodData. So I would like to demonstrate like end-to-end multi-tenancy with both MotherDuck and GoodData in near future, in an upcoming webinar, for example. And that's all from my side.
Awesome. Thank you so much, Jacek. That was great. So I know we have a few questions still open and a few already answered. So let's kind of take a look here. So the first one we'll go with is, am I understanding correctly that DuckDB is both able to be a data source and is used as a component within the GoodData platform?
So DuckDB is the engine used in GoodData, while MotherDuck is a data source for GoodData. So we first query MotherDuck and analyze large data in MotherDuck. And the results are kind of pre-aggregation we store in GoodData. And all the post-processing of these pre-aggregations is managed with DuckDB engine.
Yeah, it's a combination, exactly. So on the Cloud Data Warehouse side, MotherDuck has got DuckDB under the hood. So in that sense, DuckDB is a data source, but it's wrapped around with MotherDuck. So I think it's better to think of MotherDuck as the data source. And then, GoodData also uses that same, really efficient data engine for a lot of processing as well.
Awesome. Thanks, guys. Let's see. Oh, we got just a thank you. You're welcome. Thank you for being here. That's nice. What limits are there on the size of data you can handle, I guess, with FlexQuery?
With FlexQuery, okay. So based on like pay as you go, I would say. FlexQuery is like designed in a way that it scales not only up, but also out. And the multi-tenancy I already mentioned is by design inside the FlexQuery. Yeah, so you can like isolate workloads for each customer, but not only for each customer actually, but also for each tenant, which in GoodData means that imagine one of our customers is Visa, and Visa has like 20,000 banks as their customers, yeah, and they want to deliver analytics to their customers, to these banks. So we provision each such tenant, each this bank as a workspace in GoodData, and there is a parent workspace defining the analytics. All these tenants inherit the definition of the analytics, but each tenant has its own data filter and potentially its own MotherDuck organization. Yeah. And then like usually you analyze data only from one tenant in one duck link or even in multiple duck links, and it scales very, very well.
Yeah,
Awesome.
I think I would essentially say try it. I think what we found is that this isn't, the same as what you think of as the single node from the, Teradata days, where you're buying a physical piece of hardware and that's as big as it gets, and everyone goes to that same single node. Everybody gets their own single node. Every even query could even get their own single node if you set it up that way. So really, single nodes are huge now, and every query can have their own. So it can scale quite a lot. Please give it a try.
Awesome. Cool. This is probably for you, Alex. Can you explain a bit more about the relationship between MotherDuck and DuckDB?
You bet. So there's kind of three organizations there. There's the DuckDB Foundation, and they're a nonprofit in the Netherlands. They actually own the intellectual property of the open source project DuckDB. So DuckDB is MIT licensed, so you can build anything that you'd like on top of it, commercially, hobby, whatever you'd like. And it's going to be MIT forever because it's in that foundation. The second organization is DuckDB Labs, and that is a consulting and services organization built by the founders of DuckDB. So Hannes Muehlheisen and Mark Brasfeld, they got a team of around 20 database experts based in the Netherlands, and I work for them part-time, one of a couple contractors there. But they're experts if you want to build your own system with DuckDB inside. So if you are using it as an ingredient. MotherDuck is the cloud platform that's using DuckDB under the hood. We have a close partnership with DuckDB Labs. I'll send you a link as well in that answer as well that also outlines how we have they own a portion of MotherDuck, the founders of DuckDB, and we also have a consulting arrangement with them. So it's an innovative way to take open source to market. And so it is a different model than what you're used to seeing, but we think it's great because they can focus on making the best embeddable database. So it's excellent for good data as an engine, excellent for the open source community, and we can focus on differentiating with that cloud platform, adding those features like differential storage, making managing things easier. So we really get the best of both. It's not like some of these traditional open core models. Basically, the open core gets really difficult to use because the reason you upgrade to the managed service is just to make it easy. In this case, they are, we kind of have playing in our own lanes, and it works out really smoothly.
Awesome. Cool.
Yeah, I would like to add that, and I'm not sure why Alex didn't mention it, but there is also a huge community behind MotherDuck and DuckDB. So I definitely encourage you to join the Slack community, just like me, and contribute there, because like in many cases, even the CEO of MotherDuck, Jordan Tigene, answered many of my questions when I was building the integration. And it's really like, it really works, this community. And also do not hesitate to contribute. Yeah, I already created a couple of pull requests to DuckDB and also to LangChain, an extension, DuckDB extension in LangChain. So if anything doesn't work, if you are familiar with Python language, for example, or C++, you can fix it by yourself, and you will definitely get a huge support and great support from the community.
Well, thank you. Yeah, love to chat with you on Slack. That'd be great.
Oh, it's so nice. Let's see, here's another one. So again, I think maybe for Alex, how does MotherDuck handle larger than memory data?
Sure, that's a great question. We use SSDs, so we have attached SSDs to our instances, and so DuckDB is does very efficient spilling to disk from RAM to your SSD. And because SSDs are so fast, we found that the combination of in memory with SSD is faster and more efficient than doing distributed processing while in memory. and it's a trade-off. If you're distributed in memory, you're using RAM, but you have that network latency, you have the complexity and challenge of a distributed system. A small piece can break at any time. Whereas you're on single node, you have the speed of SSD, and you have that kind of resiliency in that single place. So that's our approach. Feel free, if you look on the DuckDB blog, the duckdb.org/news, they have a lot of good discussion about the specific algorithms where they're very strategic. They're not spilling to disk randomly where it's going to be a slow random pattern. They're doing it in big chunks, and it's pretty neat how they manage it.
Awesome. Very cool. Okay, so let's see. We have a couple more minutes. Those are the questions that we had open. I know, Alex, you kind of answered a bunch of other questions in the chat. Is there anything there that you would like to kind of touch on a little bit more or explain a little bit more?
Yeah, happy to review those. And thank you everyone for submitting them. So one is asking about if you start work on a particular use case with MotherDuck, but then your data volume expands beyond what is possible, what does the portability look like? So from this perspective, I think we've talked a bit about how we believe we've had an internal to our company kind of mental model shift where what's possible in a single node really is bigger than we expect. So I'd encourage you to try it because we think that we need a new mental model now. It's really a different world. So please give us a try. We think we can do it. That being said, if you need to move data in and out, you can read and write to Amazon S3, Google Cloud Storage, Azure Blob Storage in Parquet files, which are nice and efficient. So it's very easy to do interoperability at that layer. We also have read support for Iceberg, and we'll be adding read support for Delta soon. Open source DuckDB already supports reading from Delta. So a lot of ways we can interact with kind of that data lake environment, which is a great way to get data in and out.
Cool.
So that is one. Let's see. Next one was asking about specific benefits to leveraging DuckDB with an as code analytics tool like GoodData. I think it's an excellent ingredient both at MotherDuck and at GoodData because it's such an efficient engine and it's improving so fast. It's really an excellent building block. And so that's part of the benefit is it's a really efficient execution engine. So you get your results very quickly. Is there a free trial of MotherDuck? Yes, there is. So it's a 30-day free trial. You get the full horsepower. And then you don't even have to put in a credit card for that trial because at the end of it, we'll just bump you down to our free tier if you like, or if you love it and you want to use it, you can put in your credit card at that point and keep access to that full horsepower. That permanent free tier has 10 gigs of storage and 10 compute hours per month. So it's enough to really do a pretty cool hobby project, pretty cool demo. If you do one, we'll give you a shout out, I'm sure. So give it a try.
Awesome. And just to point out that GoodData also has a 30-day free trial as well, which you can access on our website.
Actually, we were migrated already, or my project has already been migrated to free tier. And I am running the data pipeline there every day. And I'm also using the demo quite often. And I didn't hit any limits of the free tier yet. Yeah. So definitely for small projects, demo projects, the free tier is more than sufficient.
Awesome.
That's excellent.
That's always good to hear, right?
You bet. Works as intended. Very good.
All right, you guys, I think we'll wrap it up there. Those were some excellent questions. Thanks everyone for being here. Thank you, Alex and Jacek, for joining us. Thanks for your presentations. Like I said, we'll send you the recording in the next couple of days. Make sure to follow GoodData on LinkedIn to stay up to date with all our future webinars and other events we put on. So yeah, thank you, everyone. We'll see you all soon.
Welcome to the flock.
Thank you.
Thanks.